Hey everyone, so this is the first section of the next chapter. So we're going to talk about understanding the slope of a curve at a point. So we know slope of a line, but now we're going to get into slope of a curve. So let's start by writing the equation of the line that passes through those points. So pause the video and do that. So I need my slope, so I'm going to do 6 minus -2 over -8 minus 5. 12 over -13. And then I'm going to just do point slope. So x minus 6 equals -12 over 13, x plus 8. Or you could use the 5 and the 2, whatever you want. I'm going to leave it like that. There's no reason to change it. What is a secant line? So the word secant, we know that it has to do with trig, but there's another reason why it's called that. Do you remember what a secant, I don't know if you did this in geometry, what a secant line is? It's a line that passes through a curve at 2 points. And then a tangent line is a line that touches a curve at exactly 1 point. So a secant line, if you have a curve, looks like this, and a tangent line looks like this. If you want to know why they're called that, ask me about the unit circle picture. I'll show you the unit circle picture and why those vocabulary terms are used. All right, so I made another video of this. So go pause this and go to the other video if you haven't watched it yet. So the whole idea here is we have a secant line. The secant line is just slope, right? The slope of this line. And as these points get closer and closer, that secant line becomes a tangent line, right? As we get those 2 points so they're really, really, really close together, it's no longer a secant line and it's going to turn into a tangent line. So this is our average rate of change, and we've seen this before, right? F of x minus f of c over x minus c. So whenever you see average, you're just going to think slope. Right? Our slope formula. That's our y2 minus y1 over x2 minus x1. All right, so let's find the rate of change. So we have f of x minus f of c all over x minus c. So let's see. We have 2 over x plus 4 minus f of c, plug in c, we get 2 over 9, all over x minus 5. And then we can rewrite that. I'm going to make a common denominator, so times 9 times 9 times x plus 4, x plus 4. So we get 18 minus 2x minus 8 all over 9 x plus 4, and that x plus 1 goes into the denominator. If we simplify the top, we get 10 minus 2x, which factors. So we get 2 times 5 minus x over 9 times x plus 4, x minus 5. Now x minus 5, x plus 5, they cancel, but they cancel to a negative. So our answer is -2 over 9 times x plus 4. That's it. That's the average rate of change. All right, so here's just another picture. As we find that average rate of change, it becomes the actual rate of change. All right, so as those points get closer and closer, I hope the word limit kind of popped into your brain. So the slope of the tangent line equals the limit of the slope of the secant line. So as those 2 points get closer and closer together, right, closer and closer is a limit. So then when those 2 points are basically on top of each other, it's now a tangent line. And notice if we plug in a, f of a minus f of a over a minus, it's that 0 over 0. So we always have to do some kind of math there. Okay, so find the equation of the tangent line to the graph at x equals -2. So we're going to start with our average rate of change, right? The limit as x approaches -2, f of x minus f of -2. Let's figure out what that is over here. So that's 4 minus 6 minus 1, so -3, so plus 3, all over x plus 2. So I'm just using my f of x minus f of c over x minus c, and we're going to take the limit of it. And we've done this, right? This shouldn't be anything like shocking to you. So we got the limit as x approaches -2. We got x squared plus 3x plus 2 over x plus 2. Now if we try to plug in -2, we get 0 over 0. So we're going to factor x plus 1 times x plus 2 over x plus 2. So those cancel, and then we can plug in and we get -1. So we have this parabola, right? And at, probably it's going to be somewhere around there, right? The slope of the tangent line is -1, right? So we just found the slope of the tangent line at -2. What is the normal line? So the normal line is just a fancy word for perpendicular line. The normal line is the perpendicular line to a curve at a point. There's a lot of words that mean perpendicular in math. There's another one, orthogonal. I think there's another one, I can't remember what it is. You might talk about them in physics also. So if I have my curve, right? There's my tangent line, and then I have my perpendicular line, which is also called my normal line. Calculus, they call it normal line. I know there's a reason, but honestly, I don't remember what it is. All right, so find the equation of the normal line to g of x at 1. All right, so that means we need our slope, right? We need our slope at 1. So pause the video and find the slope. We have the limit as x approaches 1 over the square root of x minus, what's g of 1? G of 1 is 1 all over x minus 1. All right, what do you think we're going to do to this one now? So it's a fraction. So since it's a fraction, I need a common denominator. So I'm going to make this root x over root x. So we get the limit as x approaches 1 minus root x all over root x, and then all over x minus 1. Now we can put those into the same, those are really the same denominator, right? So I have the limit, x approaches 1 minus root x all over root x, x minus 1. Now what do we need to do? Pretty much anytime there's a square root, we multiply by the reciprocal. So let's do that. The reciprocal. The conjugate. So 1 plus root x, 1 plus root x. So that gives me the limit as x approaches 1. So we get 1 minus x on top. Again, we're positive numbers, so I'm not going to worry right now about the the absolute value of x. X minus 1, 1 plus root x. So then the x minus 1 and the 1 minus x cancel to a negative. So remember, you're left with a -1 on top. So finally, we have the limit as x approaches 1 of -1 over root x times 1 plus root x, which is -1 over 1 times 2. So we get -1/2 is our slope, right? So m is -1/2, but we're looking at the normal line. So if we're looking for the normal line, what's the slope? So instead, our m is going to be 2, because remember, it's the negative reciprocal. For perpendicular is the negative reciprocal slope. So then I have m, and I have that point 1, 1. So y minus 1 equals 2 times x minus 1. And that's it. All right, definition, write this down. Derivative of a function at a number. If y equals f of x is a function and c is in the domain of f, then the derivative of f at c, denoted f prime of c, is the number f prime of c equals the limit. Basically, when we find the limit, instead of calling that the slope, we call that the derivative. It's just another name for slope. But the derivative of function at a number is equal to the slope. So when we find the slope of the tangent line, the slope of the tangent line is the slope of the function. But instead of calling it the slope of the function, it's called the derivative. I just talked in circles. I apologize. I wrote it down. You're going to write it down in a minute. Here it is. Okay, so the slope of the tangent line at a point equals the slope of the curve at that point. Rather than slope, we call it the derivative. So when we have some curve, right, the slope of the curve is equal to the slope of the tangent line. But instead of slope, we just call it derivative. And you'll get used to it, I promise. All right, so then find the derivative of the square root of 3x at x equals 3. So that means find f prime of 6. That should be f prime of 3. I don't know what I was doing there. All right, let's make that f prime of 3. Otherwise that wouldn't make sense. Right. So we're doing exactly what we did before. We're just naming it something different. So it's the limit as x approaches 3 of f of x minus, what's f of 3? F of 3 is 3 over x minus 3. We're going to multiply by the conjugate. So we got the limit as x approaches 3. Let's see, we get 3x minus 9 over x minus 3, 3x plus 3. And then if I factor the top, we get 3 times x minus 3. The x minus 3's cancel. So it's the limit as x approaches 3 of 3 over the square root of 3x plus 3. So it's that 3 over 6, which is a half. So that means f prime of 3 equals 1/2. The slope of that square root at 3 is a half. So think about a square root, right? It's going to look like that. At the point 3, we're saying the slope of that little tangent line is a half, and that's also the slope of the curve. So the slope of the curve equals a half at that point. But because it's a curve, that tangent line constantly changes, so the slope is going to be different over here. And that's why we call it the derivative, because it changes over time. All right, and that's it. There's your homework. Have a fabulous day.